Okay, hi guys. So let's continue with 3.3 electrolytic cell. Okay, electrolytic cell, it is different from your voltaic cell. So these are your learning objectives. Okay, so you can read it at your own time. So let's just head on to what electrolysis means. Electrolysis means that you are going to break down something. In this case, you are going to break down your electrolytes, okay, using electrical energy, okay. Lysis means apa? Lysis means to break up. So basically, you're breaking up your salt into ions lah. Okay, so this is the setup of an electrolytic cell. So one thing that you need to know about electrolytic cell is that your anode will be the positive terminal while your cathode will be the negative terminal. So that is terbalik daripada awak punya what do you call voltaic cell, okay? And your electrolytic cell, it has a battery because the battery is the source of electrons, okay? So you need electrical energy in order for your reaction here to occur. Okay, so what reaction is it? It is redox reaction lah. Redox reaction meaning that you will have oxidation and you will have reduction. So oxidation and reduction, okay, oxidation, it still happens at A naught, oxidation here, okay, and at cathode you still have reduction, okay. Yang benda ni, reduction, alright. So beza dia is just that yang ni, yang panjang ni of your battery ni, this is the positive terminal. So this A naught will be your positive terminal, okay. So what ions that will be attracted will be discharged from your electrolyte to your anode or cathode. It will depend on the positive or negative terminal. So opposites attract. So anion here, X minus will go to your anode macam biasa. Okay. So macam biasa your apa benda ni, anion will lose electron, okay, so to form a metal, and then your electron will travel through this wire and be received at your cathode, okay, and then your ion that is discharged here will accept the electron to form the metal. Yang ni tadi jadi apa? Loose electron jadi dia jadi gas ke whatever lah. Okay, depends. Alright, and another thing is that your electrolytic cell, it has one electrolyte. Alright, so the chemical reaction happens right here. Okay, you're breaking down your electrolyte. Okay, so this is the difference between voltaic cell and electrolytic cell. So obviously, you know, voltaic cell is a spontaneous reaction. So your E cell, anode cell will be positive, okay, have positive value. While electrolytic cell here is a non-spontaneous reaction because you're going to use electrical energy. You need electrical energy in order to get chemical reaction, okay. So, bacalah. Basically, beza dia, ingat satu benda yang voltaic cell is that your anode is the negative terminal, and then in electrolytic cell your anode is your positive terminal, okay. Ikut battery juga, battery. Alright, and then your electron is supplied to cathode, okay, while in voltaic cell your electron is consumed at cathode, okay. Okay, tapi awak punya electron flow will always be from anode to cathode, okay. Okay, so these are the terms that you need to understand. So ini bacalah sendiri, okay. It is basically stuff from form 5, okay. So basically electrolyte ni is your liquid that conducts electricity and has cations and anions lah. Okay, you can have molten, aqueous, electrolytes, and then your electrode, you can have innate dengan active electrode. Okay, so your source of your source of electrical energy is from your battery. Alright, okay, so how does an electrolytic cell operates? Your battery will supply electrical energy and force your reaction to occur. So the negative ions, they will be attracted. Tadi negative ions daripada awak punya electrolyte, they will be attracted to your anode. Okay, your anode will be the positive terminal. So kat sini positive. So whatever negative ions is in your electrolyte, okay, will be attracted to your anode. So anode, ingat dia positive terminal. Okay, lepas tu ni kat sini awak punya cathode. Cathode is your negative terminal. So your cation will be attracted to your ni lah, cathode lah. So your electron will travel through the wire from anode here to your cathode. Okay, so whatever is at the cathode is actually the one who will be electroplated. Okay, what you want to electroplate your cathode with will be at anode. Alright, okay, so your ions, they are discharged at the electrodes. Discharge maksudnya apa? Discharge maksudnya dia hilang charge lah. Faham tak? Okay, kat sini kan dia ions kan, boleh faham kan? Dia hilang charge. Alright, so there are 3 factors affecting the products of your electrolysis. Okay, so basically ini adalah cara untuk you to predict, okay, predict what predict what products you will get at your electrode. Alright, so you have the SRP of your species, and then you have concentration of your species and the nature of your electrodes. So kalau SRP ni, basically awak tahu kan, SRP tu awak sebenarnya it will not be provided, the whole table tu it won't be provided in your exam. So that means that it depends on the question lah, apa dia nak awak buat, tengoklah apa dia nak bagi awak. Okay, so bukannya awak kena hafal lah, tapi macam just note that. Okay, so as for, okay, kita masuklah dulu one by one. So SRP, how do we use SRP to determine, okay, what ions will be attracted, will be discharged at your cathode, and what ions will be discharged at your anode. Okay, so kita tengok if you have 2 half reactions that are possible at an electrode, okay, meaning that awak akan ada electrolyte kan, so sometimes your electrolyte, okay, awak ada 2 different cations. Okay, so if you have 2 different cations, you need to know the standard reduction potential for those species. Okay, so the more positive, the one with the more positive anode will be reduced at your cathode lah. So yang lagi satu tu bukan. Okay, and then macam biasalah, who has the more negative anode, okay, which anion, okay, cation, it will be oxidized at your anode. Okay, alright, so let's see, this is your standard reduction potential table. Okay, so ini adalah value of your species. Okay, so yang ni memang lah awak tak boleh hafal, but what you have to remember is the electrochemical series. I guess you have learned this before during SPM days. So kalau dulu zaman saya, cikgu saya ajar, please stop calling, tapi kat sini kenapa dia terbalik please stop calling my alien zebra in the club, in the pub, in the lab, sebab ni lab. Hi, cup again. So I think you guys have other mnemonics for you to remember this kan. So cation ni this ECS, it actually came from your standard reduction potential table ni lah. Okay, just that yang ni kira macam yang you have to remember. Okay, so you need to know the the arrangement. Okay, going down this series, the species has higher tendency to be discharged. Okay, so maksudnya contoh, if you have Pb2 plus and water, so between those two at your cathode, okay, if you have those two at your cathode, these ions at your cathode, then you will pick the one lower. That means Pb2 plus will be discharged at your cathode lah. So let's say if you have OH minus and Cl minus, okay, between these two, then you will pick OH minus, it will discharge at your anode. Okay, so obviously you know lah, yang anion will discharge at anode and cation will discharge at cathode. Okay, so electrochemical series ni kena ingat. Okay, alright. So when we are using SRP, we are going to use SRP in usually simple situations like when we have molten salt. Okay, so molten salt ni apa? Molten salt, can you imagine kalau macam molten lava, it doesn't have any water. Okay, so basically it is actually like contoh kalau NaCl, it is not aqueous, it is liquid. Okay, so these molten salts, it contain your cations. Okay, dan nama pun salt mestilah ada your ions kan. So in an electrolytic cell, your cation will be reduced, maksudnya gain electron at cathode and anion will be oxidized at anode. Okay, so you have to know that lah, itu generally. So your electrolysis ni of your molten salt will happen at high temperature, because bukan senang-senang awak nak have molten ions. Okay, so for example, if you have molten NaCl, so the ions present in your molten NaCl liquid ni, you will have sodium plus liquid and Cl minus liquid. Okay, so obviously you only have one cation and one anion, so there's no problem for you to pilih which ion will be discharged at anode or which one will discharge at cathode, because obviously the positive ion will discharge at cathode right here. Okay, ni ion awak, dia discharge jadi sodium, molten sodium. So basically it is sodium metal. So the observation that, or product that is formed at cathode, you can see that you have sodium metal deposited at cathode. Betul lah, cathode. Okay, so that's why you have sodium as liquid ni, it can only happen at high temperature. Okay, while at anode here, your anion, okay, it will discharge, okay, daripada charge, they lose electron and they go oxidation to form chlorine gas. Okay, so the product formed at your anode will be chlorine gas. So what do you need to know? You need to know what kind of electrolyte you have, so the ions present, and then you have to know the half cell reactions for your ions, okay, how does it discharge, and then the product that is formed at your electrode. Okay, alright, so for example, if you have molten and ABR, obviously what ions do you have? You need to know. You will have sodium plus, kan, liquid, molten, and Br minus. Okay, so what will happen? Buatlah dia punya half cell equation and get the overall cell reaction. Okay, so the products that are formed at your anode will be apa? Anode. Oxidation at anode, kan? Ni cathode. So you will get apa ni? I think terbalik lah guys. At anode patutnya bromine. Okay, betul kan So ini at anode, this one will be at cathode. Okay, tersalah. Okay, cation at cathode. Okay, betul kan ni? Okay, so you can also electrolyze your water. Why? Because water is an electroactive substance. That means that it can become an electrolyte and it can be oxidized or reduced. So maksudnya you can have oxidation. You can oxidize your water. You can reduce your water. Okay. So these two are your chemical reaction that you need to remember. Okay, ingat tak masa SPM pun kena ingat. So kena ingat lah. Okay. So obviously yang ni you are losing electrons. Okay, electrons kat sini, and you are forming oxygen gas and an acidic solution. Okay, here you are forming hydrogen gas. Okay, hydrogen gas. So nanti awak kali 2. Why? Because you want to cancel out your 4 electrons, right? And then you will form basic solution when you reduce your water, right? So when you electrolyze your water, so oxygen gas will be produced at your anode here. Okay, so from the oxidation of water, right here, ni tengok sini. Okay, and you have 1 mole of oxygen gas formed. Okay, that's your product. So when you reduce your water, you will form apa? 2 moles of hydrogen gas. Okay, so nampaklah ini 2 kali ganda. So 2 moles of hydrogen gas at your apa ni? This is your cathode, right? Okay, so that is the electrolysis of water. So why do we need to know the electrolysis? How does electrolysis of water occur? Because we will have to electrolyze. We will want to electrolyze our aqueous salt. Okay, so aqueous, aqua. That means that you will have this aqueous solution of your salt will have cations, okay, and ions and water. Okay, so that means you have 3 options. Okay, right now. So how do we pick? How do we predict what product will be formed at your electrode? We are going to look at your anode, okay, SRP. So here awak kena tahu for water punya SRP when it undergoes oxidation, and the SRP when water undergoes reduction. Okay, so that you can compare lah dengan awak punya ion lain. Okay, ions to be discharged. So let's say if you have NaCl, the ions that you have in your aqueous NaCl here, aqueous, that means you have water. You have Na plus, Cl minus, and H2O, the ions present in your solution. Okay, so during electrolysis, what will happen? Your cathode will attract your cations. Okay, so kan water molecule kan boleh kena oxidize, boleh kena reduce. That means that it can act as both cation and anion. So right now you have two different half reactions at your cathode. So which one will be, which of the ions will be discharged, which of them will undergo reduction. Okay, we need to know. So at A0 pula, you have Cl minus dengan H2O juga. Okay, so the electrolysis of aqueous NaCl, it will depend on the concentration of your electrolyte. So you can have dilute solution, you can have concentrated solution. Okay, so this will determine the product that will form at your electrode. So let's say if we have diluted NaCl, so at your cathode you can discharge sodium plus, so that is your SRP, and then you can also discharge or reduce your water. Okay, so that is your SRP. So between those two, okay, you are going to, for cathode, the cation that you are going to discharge will be the one who is more positive, who has more positive E0 cell. Okay, so basically between these two, you can see that water is much easier to reduce. So you will have this half reaction at your cathode. So that means that you are going to form hydrogen gas, okay, at your cathode and basic solution. So at E0, between Cl2 and water, okay, notice that this is an oxidation reaction. Alright, so between these two, you are going to pick the, for diluted aqueous solution, for A0 you are going to pick the anion with a more negative, okay, more negative or less positive E0 cell, okay, yang lebih kecil lah. Okay, so basically you're going to oxidize your water. Alright, so in dilute solution, water will be selected for oxidation because of its lower E0. So maksudnya apa-apa pun for diluted aqueous solution, okay, your water will be selected for oxidation, okay, because it has lower E0 SRP. Okay, so now that we've picked our ions to be discharged, okay, you are going to do your cell reaction. Okay, so from that cell reaction, you can see that you have 4 moles of hydroxide ion and 4 moles of H plus. That is actually your 4 moles of water formed. Okay, so that is how you get the final cell reaction for dilute aqueous solution. Okay, alright. So yang ni, I think you can read by yourself. Okay, baca sendiri. Okay, so sekejap ini, I want to point out, okay, let's say if you have SO42 minus dengan water, okay, so which one of these will be oxidized at your A0? Okay, which of these anions will be oxidized at your A0? Which one? So between these two, okay, water will be oxidized. Why? Why not SO42 minus? Because SO42 minus, kalau tengok the oxidation state of your sulfur here, it has reached its maximum highest oxidation state, which is 6. Okay, 5, 1, 6. So that means that kan oxidation means that you're going to increase your oxidation state kan. So SO42 minus, your sulfur here, dia tak boleh naik dah. So that's why you are not going to oxidize sulfate ion. Okay, you're going to oxidize water. So between Cl minus and water pula, okay, you are going to oxidize Cl minus. Okay, boleh ke kita oxidize Cl minus? Okay, you can. Alright, you can oxidize Cl minus when your concentration is high. So that means that concentration has does affect in predicting the product that will form at your electrode. Okay, so let's see how concentration of the species apa ni, predict the ion that will be discharged. Okay, so concentration ni, it will only apply to your anions only. So cations tak So that means what you need to know is that basically if you have high concentration, maksudnya concentrated, okay, concentrated aqueous solution, okay, your kalau ada anions, okay, except for F minus, macam if you have Cl minus, then your Cl minus can be oxidized, okay, sebab dia ada banyak. Okay, so let's say if you have concentrated NaCl, okay, so you have at cathode you have sodium plus and you have water. So between these two, macam biasa, you are going to pick the more positive one lah, so water lah. So that means ingatlah yang cations are not affected by concentration, okay, but anions, okay, so between Cl2 dengan water, okay, when this is a concentrated aqueous solution, you will oxidize your anion, your negative charge, not your water. Even though your water has a more negative or smaller E0 value, okay, so that means concentration ada special case lah untuk your anion, okay. Okay, the reason why, because of its high concentration. Alright, so that means that the reaction involved in your concentrated NaCl tadi, kita dah pilih the ions that will be discharged, okay, and you will have this overall cell reaction. So what are formed at your electrodes? So at cathode you form hydrogen, 1 mole of hydrogen gas. At anode you form 1 mole of chlorine gas molecule, okay. Alright, for this one you can read it by yourself. I think I will want you to present this, okay, explain orang-orang terpilih tu, blah 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 blah. Okay, so the third factor that will affect what your product at electrode tu, it will be the nature of your electrodes. So you can have inert electrode, okay, inert electrodes macam graphite or carbon or platinum, so they will not be involved in your reaction. So that means dia tak masuk dalam awak punya redox reaction, okay. But if you have active electrodes like metals, okay, they will become your anode. So selalunya kita akan guna active electrode ni for electroplating your cathode lah. Okay. So this metal at your anode kan you will undergo oxidation, right? So you will lose electron kan. It is your positive terminal, so the your metal will lose electron. Okay, it will lose electron to form whatever copper 2 plus ke contoh aqueous, dia masuk dalam awak punya solution, your electrolyte, and then dia akan melekat dekat awak punya cathode. So that is how electroplating works. Okay, but your electrolyte, it has to be contoh copper sulfate ke, okay, in order for your copper 2 plus to masuk kat dalam awak punya electrolyte lah. Alright, in your solution. So let's say if you perform electrolysis of copper sulfate aqueous solution using inert electrode, so your platinum will not be involved in your redox reaction here. So ini macam biasalah awak pilih apa? Ikut SRP. Okay. So tak ada pun awak punya inert electrode ni. So let's say if in this case here you have copper as your anode, right, in your electrolysis reaction here, and you have platinum as your cathode. So ingat that your electron flows from anode to cathode. So that means that this is your positive terminal. So you have Cu2 plus and SO4 2 minus, and you have H2O molecules, right? So what will happen? Okay, what is the overall reaction when your anode is made of copper? So copper is a metal that is an active electrode. So what will happen? Okay, so basically, since you have copper, okay, and platinum is your inert electrode, so that means dia tak involved dalam awak punya redox reaction. Dia just there for you to electroplate it. So whatever is your cathode here, it will be electroplated with your active electrode, given that you have copper 2 plus, the ion of your metal as your electrolyte. Okay, so how are you going to know the overall cell reaction? So you're going to, so apa ni? So you have these ions kan? So ingat tak yang your sulfate ni, it cannot undergo oxidation kan? So at your anode, if you have your SO4 2 minus will not be oxidized. Remember why? Ingat balik. So that means that your copper will be the one who will be oxidized. Okay, so your copper will lose electron. So when it loses electron, it will form copper 2 plus. So this copper 2 plus will go into your electrolyte in your copper sulfate solution. Okay, lepas tu daripada dia duduk dalam copper sulfate solution tu, okay, this one here, the copper 2 plus will gain electron to form copper solid. So yang ni, this copper solid will be deposited onto your cathode. Okay, apa cathode awak? Platinum tu. So that is how electroplating works lah. You need an active electrode and whatever metal that you want to electroplate. Okay, Okay, so if you look here, this is your overall cell equation. Nampak tak? Ni dengan ni sama kan? Equal kan? What does that mean? It means that the concentration of your copper sulfate, it remains unchanged about, the copper 2 plus consumed is being produced again, as well as the copper solid. So the copper, macam saya cakap tadi, copper here, it is transferred from your anode to the cathode through the solution copper sulfate aqueous solution tu. Okay, habis dah. Okay. Okay, habis dah. Okay, so see you guys tomorrow, and I hope you will be able to give me a proper overview of 3.2 and 3.3. Faraday's law, I will upload the video tomorrow for lecture lah, the next day. Okay guys, bye. Thank you.